dudes, and I have no idea why I always start all of my classes with "What up, dudes," but it's just kind of my thing. And by the way, for you girls out there, the dude parts that I mean is really I'm talking about the fashion-forward thinker. I'm using the 1700s definition because I'm not like, discriminating as far as genders and whatever. All right, but what up, dudes and dudesses and dudesses? Sure, let's go with dudesses. Welcome to science class. Here's what we're basically doing today. We're going to be continuing on with this Fruitville discussion. You guys were here for this lab, or some of you were here for this lab. Let me kind of share with you what we did with the lab today, and we're going to kind of go through that as far as for class today. Sound good? Some of you were wondering why class started at 10:45. It's because, oh wait, you can't see my screen? Are you the only one, Jonathan? Because it looks like everyone else can see my screen. All right, Jonathan, what you're going to need to do is there's a bunch of gray boxes everywhere. And the gray boxes is the different like windows that you can open up within this window of Canvas. And so you just kind of have to make that thing bigger. Yeah. Or you can log out and log back in. That usually almost always works. Got it? All right. We always start at 10:45 all the time. I think originally one of my first emails came out and I said 10:30, but then I asked you guys if it would be all right if I move it back to 10:45 to kind of give you folks that 15-minute break that you might want in between classes so that we don't go lab back to back to back to back. And then also gives me a chance to kind of prepare for the lab and whatnot. So if that is all right with you, that's what I asked if we can do. And in your calendar as well, I think I move everything back to 10. I tell you which assignments you have coming up, or what classes you have coming up, and they're all set to 10:45, I believe. All right, let's see. Yeah, attend virtual class. Today is the 24th. Attend virtual class at 10:45. Attend virtual class at 10:45. Awesome. Yes, and Dylan, you never check your calendar. My answer to that is check your calendar, my friend. And the reason being is because I'm not doing the whole thing about what am I talking about? I'm not doing the plan anymore. What I'm doing now is I'm basically just putting it in the calendar. So if you need to check your calendar, you need to, if you want to know what's coming up, you should be checking on your calendar. And what do you mean, who's that I'm talking about? The water contamination handout slide was blank. Is it supposed to be like that? I'll tell you what, why don't we spend some time today fixing up the class, because it looks like it's a little bit broken. I apologize. All right, let's see. Water contamination slide is blank. Let's look at this homework. You're talking about the handout. Did I say Dylan? Did I call you Dylan?
Yeah.
Oh, I'm so sorry, Quinn. You're right. I didn't even realize. No, it's not blank. I don't know what you're talking about. Whoever said that this is blank. Oh. Oh, I see. You're talking about these slides are blank. Oh. Okay. I'll tell you what I'll do then. Since I screwed that up, I will take that assignment. And here's the beauty of me using the calendar system. I'll show you. Ready? I'll take that particular assignment, the water contamination assignment, and I'll say, Mr. Dalday screwed it up and he needs time to fix it. So, to much of the advantage of everybody else, what are you talking about? I always check my inbox. Are you kidding me? I'm just, all right, fine, maybe, okay. What I did was I took your water contamination assignment and I pushed it back to Thursday. Sound fair? Sound fine? So maybe on Wednesday I'll have a chance to cover that. Yes. So your only homework that's due today is the human's need for water, or something like that. And I lectured on that last week, I think, Monday. Yeah, if you finish that. So the water contamination assignment, don't worry about it until Thursday. In fact, I'll probably give you more information on how to get it done really easy today, or on Wednesday. Sound cool? All right. Let's go back to the classroom, and actually let's get started up on some of the stuff I wanted to cover today. Did I fix everything, or is anything still broken? There's an assignment on waves and on the string, and also the scientific method. I still need to grade those, and I haven't done that yet. Boy, I didn't do that one yet? I thought I did. Huh. All right. What are you talking about, Q3? Oh, you don't understand question 3 for the water contamination. Well, okay, but I moved it back so that way you have more time on it. So we'll cover that. Why don't we talk about that assignment on Wednesday? I'll tell you what. Why don't I push that Thursday assignment back to Friday now, and then we'll have a chance to talk about it on Wednesday. Sound good? All right. Yay, even better. Yes. Okay, so let's do a couple of these. All right, I wanted to talk about the Fruitville groundwater investigation. And here's the reason why I wanted to talk about this kind of stuff is because, can you guys see my computer screen and the presentation that I have up there? All right. I feel like I didn't do a really, actually, it's not that I didn't do a good job. It's that I feel like on Wednesday, I introduced this investigation that we're starting up called the Fruitville groundwater investigation, and I didn't record it. I didn't archive it because we don't. I don't do virtual classes on the days I have labs. So today I'm going to kind of spend some time catching the people who didn't make it, and also kind of filling in all of those blanks for the people who didn't attend lab on Wednesdays. So we talked about a percent. What does the word percent mean to you? Out of R of 100? Yes, exactly. Out of 100. Because the word cent means 100, right? Like century or centurion. A centurion is a soldier. That particular soldier has 100 men under his command. And I say his because we're talking about Roman times, and I think only men were soldiers back in the Roman times. Or a centipede has about 100 legs. I have no idea how many legs a centipede does, but it definitely has less than a millipede. And a millipede is that smaller one that has like a whole bunch of legs coming out of it. Does that make sense? A century is 100 years. 1 cent is 1 out of 100. So anyway, percent is out of 100. What would a per mil? I don't know. What would it be a per mil? I'm just wondering. All right, it would be out of 1,000,000. Exactly. I just made up the word. What about a per bill? It's not something we use very often. We just call it, it would be per billion. Very good. Awesome. Now, how would I make 10% of a solution? Like if I wanted to have 10% orange juice, 10% concentrated orange juice, what would I do? Well, what I would do is I would take 1 cup of pure orange juice, pure, like straight from the orange, squeeze it out into a cup. Got it? And then I would mix it in. I would put it inside of my pitcher, and then I would take 9 cups of just straight water, and I would mix it all together. That is 10% solution orange juice, which is how my mom likes to make it because she is so cheap that she doesn't like she likes mixing in and really diluting things, so it just tastes like junk water. I don't know if your parents kind of do that, but my mom mixes her Kool-Aid, and basically it just looks like slightly pink water. It's pretty gross. Anyway, because she wants to like save it, and so she only puts like one little spoonful of Tang or something like that, and puts like 100 teaspoons of water. Super gross. Anyway, that's 10% solution. What you would need is like if I had 10% solution of food coloring, that would be 10 grams of color pigment to 90 grams of water. That would give me 100 grams of something, and 10 of those grams, 10 out of the 100, is pure color pigment. Does that make sense? And this kind of tripped a lot of people up when we covered it. All right, parts per million. I don't have my fancy animations on here, so I guess I'm giving you the answers as well as I'm giving you the stuff. Do we need to turn in our paperwork from our face-to-face class? Quinn, my answer to that is this. Your paperwork from your face-to-face class will help you out with the next assignment, so hold on to that. All right, so my question is, which is bigger, 1 million or 1 billion? And Isaiah says oh, wow, that's big. All right, it's a billion. A billion is bigger. Which quantity is larger, one part per million or 1 part per billion? It would be 1 part per million. Even though million is a smaller number, you're dividing by a smaller number, hence you're getting a bigger number overall. The activity. What we did was we did this thing where we put food coloring, and then we diluted the food coloring in successive amounts of water. And we found that, actually, you know what? What I should probably do is, for this particular lab, I'm not going to kind of talk to you and tell you what we did, because I think what would be much more fun is if we went over, or if I actually probably did the lab for you guys. So let's hang out on that one. But I just wanted to introduce to you the concept of percent and all of that kind of stuff. Anyway, we're going to start testing the waters of the Fruitvale things. So, introduction. We broke them into groups. And I didn't tell each team this, but basically, they only were able to test 12 different testing sites. The reason being is because the story I had was, your team has $36,000 for research, and it costs $3,000 to drill a well and test a well. So how many times can you test a well? Well, 12 times. All right. But we skipped that part because we just kind of decided to just go straight into the testing. So I broke the people up on Wednesday last week into 6 different groups. Group 1 had to test wells 1 through 12. Group 2 had to test wells 13 to 24, 25 to 36, 37 to 40, and then 6 to 13. And then Group 5 got to test these random samplings of wells. All right. So 1 ppb is 1 liter of water for 1 billion liters, or 1 liter of poison for 1 billion liters of water. 1 billion liters of water is enough to feed. All right, so here's how much 1 billion liters of water is. All right, let me just give you an idea of the scope of things. With 1 billion liters of water, you could feed a family of 4 for 36,000 years. Or, I guess if you wanted to think about it, maybe you could feed 36,000 families for 1 year. All right. Health officials have actually decided that you can drink pesticide if it's 1 ppb. You can drink poison if it's 1 piece of poison for every billion pieces of water you have. Now, personally, I would not want to drink any parts per billion. You know what I mean? Like, I would want 0.01. Yeah, I would rather have the non-contaminated water. But, to be honest with you, is that reasonable to ask? Can you ever get super pure water that has no contaminants in it whatsoever? See, I don't think that that even is like I don't think you can.
Yeah.
I think you can get it within these tolerance ranges. Not even before, because like
maybe a pretty long time before.
all right, maybe before we put in all of this junk into our water system and we put pesticides into the air and whatnot. Maybe.
Right.
But then again, way back then, you wouldn't have had the equipment to test whether or not something was how pure the water was, so you wouldn't care. All right. So, here's some terms I want to go over. And it doesn't have this nice, pretty transitions and all of that kind of stuff, so I'm just giving you the whole slide one time. An aquifer. What is an aquifer? An aquifer is a bed or layer of the earth, it's gravel or porous stone that yields water. An aquitard is a water-saturated sediment or rock whose permeability is so low it cannot transmit any useful amount of water. Groundwater, what is that? Water that exists below the Earth's surface in underground streams and aquifers. Cool. Permeable. What is permeable? Because I use the word permeability up here, and you guys are like, what are you talking about? Permeable, if something is permeable, it allows fluid to pass through it. Is your clothes permeable? Yes. Is your umbrella permeable? I would hope not. And I had to use an umbrella this morning. And preferably, you don't want your umbrella to be permeable. You know what I mean? You want it to kind of like not allow water to pass through it. All right. Porosity or porosity. It's the structure that is part. Is a structure or part that is porous. Well, what does porous mean? What does porous mean? I mean, I'm using a confusing word to define another confusing word. Does anyone have any idea? Yes, pores, as in holes. My wife, oh, I can't stand it, but she loves popping my pimples. And I think about you guys are about at that age where you're getting lots of pimples. And why do you have lots of pimples? Because you've got big old pores in your head. Right? And pores are holes inside of your head where bacteria can start growing and little pieces of grain or sand or whatever will start kind of getting some kind of infection around it, and that's called a pimple. And that's what you pop when you and so Mr. Dalday still has big old pores, and then he doesn't even like I wash my face, but I'm just saying like I stopped putting on acne cleaner or whatever. I don't care. I'm married already. I'm not trying to look all good and stuff. Anyway. She still pops my pimples because I've got big pores. All right. Right. And again, Mr. Dalday loves telling you folks ridiculous stories because it helps you remember things better. All right. So here is kind of here's kind of a good picture of an aquifer. An aquifer, like, it's underground water. And you could have an aquifer that is way deep down underground. And that's called a confined aquifer. And then you have the unconfined aquifer, which is basically like the lake water, but then way deep underneath that. Does that make sense? And you could tap straight into that underground unconfined aquifer if you dug a well. So there's our well. All right. So, paragraph 1. Let me introduce to you. Yeah, no. It's bedrock as in a rock of beds. A bed of rocks. A rock of beds. That doesn't make sense. A bed of rocks. That's what I mean. All right. Paragraph 1. Let's talk about that. So, let me introduce to you the story of Fruitvale. In the summer, it is summer, and you are home from college, visiting friends in Fruitvale. They have a small house and a very big yard. One big enough for chickens, a vegetable garden, a pond, 2 horses, and when you arrive, you find that they are drinking bottled water instead of water from the well. They tell you that the water from the pond, which comes from the underground aquifer, smells funny, or has smelled funny lately. They don't know whether it's safe to drink the water from their wells and are afraid that the garden might be contaminated. You're not happy about this. You've been studying about groundwater and water contamination in college, and you've decided to investigate. So, questions. What are some things you could do to determine that the water is contaminated or not? And I'll be honest with you. Actually, yes, I'll be honest with you. Here's the thing. This thing was supposed to have just this part right here, and then these answers were supposed to fly in. So just tell me the answers then, okay? Because I can't switch it up. All right, see if it tastes funny, okay? Personally, yeah, I was gonna agree with Jonathan. I was gonna agree with Quinn. If I think that water is contaminated, I'm not gonna drink it to try to see if it's contaminated. I mean, I might have mice drink it, maybe, but like I ain't drinking it. Boy, this water is green. I wonder if it's bad for you. Drink it. All right. So I agree with Quinn, except the fact that he's calling me cruel for testing things on mice. Well, we do it all the time. All right. Some other things you could do is call the water company to find out if there's a toxic leak has been reported. Or look at the water under a microscope and see if there's strange things there. Or find any neighbors and see if any of the neighbors or the pets who've been drinking the water, like Jonathan, has actually gotten sick. There we go. All right. Paragraph 2. So, here's what you do. First, you check the pond. It does smell funny, but it always smelled funny to you. Next, you ask a friend, your friend's neighbors, the Andrews, whether they've noticed anything wrong with the water. And your friends and the Andrews are the only people in Fruitville who still get their water from their own wells. Everyone else uses the city water. Miss Andrew tells you she hasn't noticed anything unusual, but does mention that her dog has been sick and wonders whether the dog drank some bad water. Okay, there we go. So, what have we learned? Ooh, this is good. We can type it in. What have we learned so far? No, I said nothing about milk. I have no idea, Isabella, why you're talking about milk going bad. The water does smell funny, yes. All right. What else have we learned from the previous paragraph? Don't drink green water. You guys are going, it's doggy's sick. I love it. Dog sick. Sick doggy. All right. And Andrews didn't notice any contamination. Okay, interesting. All right. What additional evidence could we find out if the water is contaminated? Well, maybe we should try to look for, well, where does the doggy like to drink its water? Does it go? Yeah, does it go into the other people's yards? Does it go into its own yard? What I would do is I would have a veterinarian go in and cut the dog open and do an autopsy and see. No, wait, the doggy's not dead yet, right? Okay, all right, never mind. I would go into the veterinarian and have them examine the dog and see if that, see if the dog is sick because the dog drank water, or the dog is sick because the dog went out and drank like antifreeze, or maybe the dog is sick because the dog has fleas or something like that. If the dog has fleas, then the dog doesn't necessarily, I mean, then you can't necessarily say, oh, the water's bad. You know what I mean? Yeah. You could test some sample waters. You could send some sample water to the laboratory for testing. Very good. Awesome. Paragraph 3. There's a lot of paragraphs in this story, but I'm trying to introduce, I'm building a picture for you to kind of give you folks some context as to what we tested when we were doing our lab. Cool? All right. You begin to make a map and record what you find out. Much of the neighbors have changed since you began to visit your friends 8 years ago. There are many more houses and fewer farms. The old country school has been replaced by a large school and playing fields. The dry creek has been cleaned up since you and your friends used to make forts of scraps of metals and wood that you found out there. Hold on 1 second. Someone's calling me. I cannot answer you right now. I'll call back. Sorry. Let me put that on silent. How embarrassing. There we go. All right. So, now part of the creek below the highway is a park. Finally, your map is complete, and you stop at Randy's filling station to have a cold drink. Let me show you the map of Fruitvale. Here's the map. It's kind of a hard map to see. I wonder if I have a better map. Let me see. We're just talking about pizza. Here we go. Here's the map. Got it? I think that this is your friend's house. And your friend's house has horses, and it's got its own farm. I think this is the Andrews house way down here. Yeah, see, your friend's house is right over here on this corner. Here's Orchid Lane, and here's Andrew's house. So let's see. Your friend's house is on the corner, like I said, and Andrew's house is way down here. Got it? This is a picture of Fruitvale. Fruitvale. Not Fruitvale. Fruitvale. All right. Look for one of the things we need to do is we need to look for places where possible sources of pollution. Here's my question: do you think Randy's filling station could be a source? I don't know why this is weird when I typed it. Do you think that Randy's filling station could be a source? Seamus is completely... See, what Seamus did is when he did the lab, he thinks that it is... He absolutely is convinced that it's right over here where there's a big trash dump. And Randy's filling station, I believe, is like this around here. It says gas over here. It's kind of hard to see. There it says gas. Here, it's easier to see on this map over here. Randy's filling station right there.
I could have a leak.
Yeah. So do you think that could be a source? Is the water green or black? Well, see, the thing is, all of the water is clear. All of this water that we're looking at is clear. And Seamus is absolutely convinced that it's from the trash. Okay, Seamus, duly noted. That will be your hypothesis, my friend. My question is, do you think it could have come from the filling station? And the filling station, by the way, is the gas station. That's what I mean. Maybe. Yes, because of gas. What does gas do? Well, the gas could have leaked from the gas could have leaked into the water. So the reason why I'm talking about this is I want to introduce you to a concept. This is called a point source pollution. This means the solution is, or the pollution has come from a single point source, a single place. In this case, maybe it would be, you know how like at Costco they have the gas trucks that come over there, and you ever see the trucks go in and fill up, like basically place a hose into the ground and fill up the ground with gas? That's because there's giant tanks underneath the ground, right? Imagine if the tank had a crack on that bottom of that tank. Well, that would be pollution coming from a very specific source. And that's what we're talking about with this point source pollution. What do you mean you can't see anything? You can't see my computer screen? Okay. All right. If you guys, no. It's not that you're blind or anything. Maybe, Arona, what you might need to do is log out and log back in. Okay. So what we have here is we have a point source, and you can see that the pollution comes in what we call plumes. This is really important stuff. The plumes is it kind of it kind of like spreads out from this one point. And maybe the reason why do you think that it spreads out this way and not up this way?
Can be incline.
Yeah, I want to hear what other people think. By the way, I have Joshua Knight sitting next to me. Because of gravity, I totally agree with you. Yes, exactly. We have different elevation levels, and it looks to me like this pollution kind of travels downhill. And the most concentrated pollution is in the center, but then as you go further and further away, you have different levels of concentration of the thing. These are called the plumes from a point source. There's another type of pollution, and this one we get a lot of in Hawaii. It's called an area source. It's where the pollution doesn't come from one specific area or one specific point. It comes from a large area. For example, when when Kilauea erupts and it puts all of how many of you are asthmatic? See, I'm asthmatic, and when the volcanoes kind of put a lot of their fog up in the air, it really bothers my asthma. Well, that asthma is kind of triggered by that fog, which is a large area, because the volcano puts up a whole lot of stuff, and that all that sulfuric acid that's inside of the clouds and whatnot spreads out over a super large area, and so that would be more of an area source pollution as opposed to a point source pollution. All right, back to Randy's. What substances might be stored at Randy's that could be a possible pollution source? Well, I think one would be gasoline or oil. Yeah, there we go. Maybe Randy's is also doubles as a car, like does car maintenance. They change out all the oil and they dump all the oil straight into the ground, right? You shouldn't do that. They have bathrooms. Well, everyone has bathrooms, so that wouldn't necessarily be the other part. Anyway, all right. As you're finishing your map, Randy mentions that the water from the well drilled in Fruitville Estates is contaminated with pesticides. Where was Fruitville Estates? Let's look. Fruitville Estates. I guess that would be this one right here. A well drilled. I think that's this one right here. X. Is Fruitville a real place? Actually, it is. It's up in Northern California. Yeah, it's a BART station. It's like their version of a subway. But this investigation is kind of a made-up investigation, though, because I thought it'd be cool to investigate it. Yeah. All right. So this well over here contains contaminants. So let's keep reading. As you were talking to Randy, some city water department workers pull into a station. Randy tells them about your investigations, and they ask to see your map. Impressed with your careful investigations, they ask for your help, which is kind of sad because if they were working for the city, I'm assuming they're not going to ask for your help if you're like a 7th grader, or maybe in this case you're a college student. But we're talking about you here, and you are incredibly smart 7th graders. So maybe they recognize that and just be like, well, you're our town genius, so let's ask that guy. All right. What could have caused the pesticide contamination? All right. I don't know how to pronounce this correctly. I apologize if I mess it up, but it's leachate. Anyway, it's a solution that is produced from liquid leachate. Basically, what happens is, imagine, and we're going with Seamus's thing here. Oh yeah, that's right. What time is class supposed to be finished?
12. Well, no, that's Wednesday.
Yeah, today we're supposed to be finished at 11:25, I believe. Oh, man, oops, I'm sorry. I'll tell you what, how many slides I got? All right, do you mind if I just finish off 4 more slides? Is that all right? All right, leachate. Here's what's going on. Because this is Seamus's thing. I don't know why Seamus is stopping me when this is Seamus' thing. Imagine you got a bunch of trash over here. A landfill, right? It's got a bunch of trash everywhere. And what happens is the water comes down, as like it rained last night, and the water rains on top, and then the water flows through all of the trash that picks up all of the chemicals and all of that gross stuff and all of that kind of stuff. And so basically that water, that the trash leaches into the water. That would be kind of the idea behind that. What could have caused pesticide contamination? Well, I think that roadside spills or illegal dumping, like no dumping, fine, $500. And I saw this sign and I was like, wow, that's ironic. All right. Improper residential applications. For example, what if somebody had a septic tank underneath? And do you know what a septic tank is? Septic tank contains all of your poop. And what happens if that poop tank has a small little crack in it? Oh, that's gross. Anyway, have fun. Okay, and what other things? Well, you could have leaks from holding tanks at the Eden Agricultural Chemical Company. Remember I told you that there's other places around here? And let's see, there's a chemical company. Like there's actual chemical company. And what happens if they have like pollution leaks or something like that?
They produce a lot.
Yeah, they produce some things. And so you could have different pesticides leaking into the water and killing fish and hurting turtles and making the ocean a pretty looking oil color painting. Are we cool? So I apologize, I didn't get through all of my paragraphs that I wanted to cover today. I'll tell you what, I'll finish paragraph 5 and then we're pretty much done with this entire thing. I'll post this PowerPoint up to the thing. Let's do it. A pesticide has been found in the Fruitville escapes to be 5 parts per billion, 5 times the safe drinking level. This well is marked with an X on the map. The manufacturers of this pesticide originally thought that it would be safe if used properly because the chemicals would break down into the soil. Later tests have shown that the pesticides did not decompose as expected, and is banned from the United States 8 years ago. City officials have worried that the pesticides may have reached the main wells located near the bottom of the map. Your help is to decide where to test the wells need to be drilled in order to determine the source of the pesticide and the extent of its spread. So that's what we did last week, Wednesday, is we went through and we actually tested all 40 of these wells, and then I actually posted all of this information onto a YouTube video, and I'm going to have you folks from the YouTube video, from the information, put in the different codes that the wells are rated at. Cool? So for now, what we have is Fruitville looks like this, and you're seeing 5 parts per billion. That would give it a code of
Like
4.
4.
That would be a code 4. So you notice that this thing right here is code 4. Alright, looks like everything stopped working, which means it's a perfect time to finish class. See you Wednesday. All right. See you Wednesday.
I can hear you.
No! Glitch, cutting out, dying. Alright, sorry. I'm sorry. Apologize. Alright, stop the thing. Stop this. Stop recording.